Hello everyone. Hello everyone. Today we are going to see Podands. So as we have already discussed about the cyclic analogs like crown ethers, today we are going to see about the Podands. So I am Dr. Gerald Anthony, Assistant Professor in Chemistry, St. Xavier's College, Palayam Kottai. So in the previous classes we have discussed about some of the host-guest chemistries related to fullerenes and crown ethers. In this class we are going to see about the Podands. So Podands are acyclic hosts. They will be having structure similar to that of its cyclic analog like crown ethers. So they will be more or less like crown ethers. So this is an example. Here you can see there is no cyclic structure, it is acyclic. So I have marked it with the yellow color. So it is acyclic, there is no bond of attachment. If there is a bond of attachment, it can be called a cyclic host, that is nothing other than that crown ethers. So this is a basic example for a Podands, which will be very much similar to that of crown ether. Only one thing difference between the crown ethers and Podands will be crown ethers are cyclic and Podands are acyclic. Another important thing is Podand will be having less affinity for the cations. So there is no need for it to get pre-organized its structure. So the extra flexibility of Podand host will make, so it is since it is acyclic, it has extra flexibility. So now what happens, it allows them to engage in bridging and helical bonding modes, which is not possible for crown ether. So it can involve in bridging. So in this type of bridging, so since it is acyclic in nature, so it will be having some bridge like arrangement, bridge like attachment with the host. And another important thing is helical bonding modes. So in this way it will be having helical bonding mode. And this is another one Podand. You can see it is having a long chain of alicyclic compound attached to it. So it will be having lipophilic nature. So calcium 2 plus can be easily absorbed inside this Podand, and it can be linked to a through a polar amide group. So here the host ability of this Podand is mainly due to the polar amide group present here. It will make the guest to bind tightly to the host, and it is due to its lipophilic nature, its membrane transportability will also improve, and it is able to transport the calcium ion from one lipophilic nature from one membrane to another membrane, from hydrophobic to hydrophilic, for example. We can say like that, hydrophilic to hydrophobic. And the term Podand was coined by the researchers Vogel and Weber in 1976, whose work also early involved in quinoline terminated Podands. So the Podands in which the terminal layers will be quinoline like structures. So also it forms a stable crystalline compounds with variety of alkali metals as well as transition metals. So it can form host guest complexes with alkali metals as well as transition metals, and also even with uranyl nitrate it can form host guest complex. So here you can see this is a structure in which the terminal rings are terminated with quinoline. So this quinoline can terminate, and it makes this acyclic Podand to somewhat to become less flexible, and we can accommodate more number of hosts from a range of alkali metals to transition metals and even to lanthanides. Up to lanthanides we can make the metal ions to bind inside this host. So the end group concept which comes into the existence. What do you mean by end group concept? Since it is acyclic, these podans can move here and there. Okay, there will not be a proper arrangement of the chains. So this leads to the movement of podans away from the guest. So to make it a rigid structure, as I have already mentioned, they have terminated with a rigid functionality like aryl group or a ester group. Okay, we can use an aryl or ester group to make this structure rigid. For example, here you can see, here they have used the benzoic acid moiety here, which will make this group to be present rigid, so it will partially pre-organize. So the pre-organized means it will be partially rigid, so it will be having a pre-organized binding cleft. So now what happens, we can make this guest to enter into this acyclic analog podand, which is terminated by a benzoic acid, and it can remain stable for some more times. So here, in using this rigid end group, we have synthesis. The researchers have synthesized such a cyclic podans. So in this, you have terminated it with a quinone monoimine group. So the quinone monoimine groups will be there. So I have encircled it, and this quinone imine, in this quinone imine group terminated podand, we can make the calcium ions to bind into it. So the calcium 2 plus ions can bind into it, and it will be the presence of this cation can be sensed in the UV visible spectroscopy, and so it is also known as chromoionophore. Okay, such type of podans, host guest podans, are known as chromoionophore. And in general, we should note one thing, that compared to the cyclic analogs like crown ethers, ferrans, and kryptons, this host guest binding ability for podand will be very less. So thank you. We can see in another next video lecture.